number of oscillations per second. Heart pumps the blood to the different body organs.
Both statements aren't true, it is always true.
Hi, hello dear Tswreis. My name is J.Mounika and now we are going to discuss about the sets chapter, and the sets is an important one in the mathematics. Now what is sets? Sets is nothing but a well defined collection of any object is called as sets. I will say you some slide. Here you can see the slide here. The set is a well defined collection of objects. And what is a well defined collection? Don't you get any doubt? A well defined collection means any object, if we take any set here, if we take any object or inside the set, we should be able to say whether it is belong to that set or not. And the set elements in the set should have any common feature or common property in between them. It means you can see the example here. Players of a Indian cricket team, rivers of India, and students of TSWRS, members of a family. Here we got here some examples. Now if we take an Indian cricket team, we can say who are the members of Indian cricket team. They are, we can say anyone like Sachin, Dhoni, Kohli, etc. And if we ask anyone to say the team of a cricket team, we can't say, because there are so many members who are the players of the cricket team. If we mention here we have mentioned that Indian cricket team. So by this we can say a list of them. Here it means the well defined means particularly we can say whether the elements or belong to that set or not. For example, well defined means, now we can take a set of natural numbers. We know that set of natural numbers start with 1, 2, 3 and up to so on. And if we take any another example, 0, can we say this belongs to this set or not? Yes, we can say 0 is not the set of the element of the set of natural numbers. 0 is, if we add 0 to this, it will become whole number, and we can consider this as a well defined collection. And like these types of collections are togetherly known as sets. And set is highly developed by a mathematician called George Cantor. Here is, you can see this picture. He is George Cantor. He developed the sets a lot, and he was a German mathematician, and bestly he was popularly known that he was the inventor of the sets theory, which has become a fundamental theory of mathematics. Cantor established importance of the one-to-one correspondence between numbers and also between relationship between two sets, that is defined or not defined and well ordered sets, and proved that real numbers are more numerous than the natural numbers. He also defined the cardinal and ordinal numbers of the arithmetics. You can see his picture here. He is the George Cantor. He developed sets And now we can next, this is the mind mapping of sets, and from any object or there here, from any objects, whether it may be objects, numbers or anything else, from that a well defined collections, if we take any, it means the numbers or anything it else may be, and the well defined collection, from that the well defined collections togetherly is known as sets. In that sets, there are subunits, naming of sets, elements of sets, representing sets, types of sets. Here now I will explain about the naming of sets. From now on, now we learned about sets, what is sets, and now we have to name the sets. Naming of sets. Usually we have many sets, but how to recognize those sets? For example, we take any set of whole numbers. It starts with 0, 1, 2, 3, 4. If I did not represent W, how you could say that it is the whole numbers? And now we have to represent a word or anything to recognize this. That is W. Whole numbers is denoted with W, and it must be in a uppercase letter. Uppercase letter is nothing but a capital letters. Definitely if we denote the set with anything, that should be definitely uppercase letters. Uppercase letters means any capital letters, we can denote anything, but these whole numbers is denoted with the capital W. And now we can take any sets, they definitely they should have one representative set of natural numbers. We will denote with capital N, and anything else, we can take anything else. Now here we can see the set of natural numbers is denoted with a capital letter N, and next integers with Z, and rational numbers with Q, real numbers R. And if this is called a set, and we will denote this with a capital letter, and inside the set, the elements or any objects inside the set should be denoted with it means lowercase letters. Lowercase letters means nothing but small letters, or maybe if we given any question in capital letters, we can represent that with only capital letters. Here you can see the slide. Sets are usually denoted by the capital letters, A as A, B, C, X, Y, Z, and etc. The elements are the elements inside the set is denoted by small letters as A, small a, B, C, etc. Here now next we go to next thing, elements of sets. Elements of sets means here we take the whole numbers, the letters or anything we wrote in which we wrote inside the set is called as elements or objects or members. These three are called synonyms. That what elements, objects, members. We call these the objects we wrote inside the set are called objects. Elements, that is if we take the number 1. Number 1 is belong to that. What is belongs to? Belongs to means this is a part of this set. We in the mathematical language we used to say this write like this. This means belongs to. This indicates belongs to. Please note this, friends. This is a Greek word and this is epsilon. Epsilon. Please note this. And if minus 1, if we take number minus 1, the minus 1 is not part of this, and we can write that minus 1 is does not belongs to W. Does not belongs to, this is called as does not belongs to, this called as belongs to. Next, now we have to represent sets. Sets usually represented here, please see the mind mapping. Now we learned about naming of sets, elements of sets. Now we have to represent sets. Usually sets was represented by roster form, set builder form and Venn diagrams. Now I will explain you what are these. Roster form, first one is roster form. Roster form. Now roster form is, if we take any collection, it means set. If we take any set, if we write in the roster form, that the set should be, the elements inside the set should be separated using commas within the curly brackets. Means now if I took a set A is equal to, is the set has 1, 2, 3, 4, 5. In the roster form, we have to represent A is equal to 1, 2, 3, 4, 5, and we have to close this by using curly brackets. The elements, please note this, the elements definitely should be separated using commas, and that should be closed by using brackets. And the important thing, the crucial thing in it was the elements inside this were not repeated. It means were not repeated. We cannot write, if here there is set as 4, 3 again. We got here twice at times 3 and 4. If we write this as set, definitely we have to write only one time. The numbers should not be repeated. Please note this. This is the crucial thing. And next, this is the roster form. We can write roster form in always if n is equal to ovals A, E, I, O, U. Definitely we have to close this by curly brackets, and we should use the commas. And next one, set builder form. Set builder form. The set builder form is used by a pattern, and we should have that the set which we used or written should have a common property between them, and that is represented using a pattern. It means here we ovals, now we have written in the roster form, and now we will write in the set builder form. Set builder form, V is equal to X such that, please be careful, we should not use semicolon, we should use only colon. X such that X belongs to ovals in English alphabets. And now in this set, the elements inside set have some common feature, and we have to write that using a pattern. The pattern should be in a sentence, and we have to represent that sentence. Here I wrote a wrong. Look here, I wrote that ovals, and the important thing here is we should not write that plural word. We have to represent that X such that X belong to a oval. Means that oval may be any word as A, E, I, O, U. That oval in the alphabet may be any number in this 5 letters, like this. We have to, and we can write this in another form. Look here, we can write this like this, X such that X belongs to oval in English alphabets. Now I will show you a slide. Roster form is also can be called as tabular form and set builder form. Roster form. Here in roster form, all elements of sets are listed. The elements are being separated using commas and are enclosed within the braces. Braces nothing but brackets, and it should be curly brackets. In the roster form, look that the important point, in the roster form, the order in which elements are listed is immaterial. Immaterial means that no need to be any in order. If we have that A, E, I, O, U, we have written A, E, I, O, U. Here in this pattern we can write as E, A, I, O, U. This is also the correct sentence in the roster form. It means the order is immaterial. We don't need to be writing this in a order. Next, the set builder form. See the slide please. Set builder form. All the elements of a set possess a single common property which is not possessed by any elements outside the set. Here the set, in the set builder form, all the elements which are in the set should have any single common property, and there is no need to be another word. Next, for example, in the set A, E, I, O, U, just now I said all the elements possess the common property, namely each of them is a vowel in the English alphabet. They are the vowels. In the 26 alphabets in English, these 5 have separate feature. They are the vowels. Only 5 are the vowels, and no other letters possess this property. Next, denote this set by V. Now we have V is equal to X such that we can call they are the colons, and we can call like this X such that X is a vowel in English alphabet. Next thing here, next one, what is the next one? Venn diagrams. Yes, and the sets are represented as Venn diagrams. What is Venn diagrams? These are the some diagrams. Sets is also can be represented by using Venn diagrams. Venn diagrams are usually denoted with a rectangle. In that we have to use a circle. Now I will say you some example. One example, A is equal to 1, 2, 3, 4 and B is equal to 2, 4, and now we can denote this as B, this as A. Here in the B we have 2 and 4. Next is we thought that it was A. In here 2 and 4 was the common thing, and the remaining 1 and 3 were remained, and that can be represented here 1, 3. And the important thing here is this is represented using a word mu. Mu can be written like this, like this, like this usually, and it is called as mu. Definitely we have to represent this by mu. These types of diagrams are called as Venn diagrams, and it would be easy to learn the sets using Venn diagrams, no? And the points here, we have to represent points. It is used to say that it is written by a rectangle and a circle inside. We can write the Venn diagrams in another form also, in another ways. If we have, now we have only one set in the rectangle. And now we can there is only two sets, we can represent two squares here. Here same one, mu, and in this case if it is A, it is B, we can represent 2 and 4 like this. Next one, types of sets. Look here, types of sets. In these types of sets we have null set, singleton set, finite set, infinite set, universal set and disjoint sets. Types of sets means here the types in the sets or different kinds in the set. The first one is null set. Null set. Null set can be called as empty set or void set. The null set is nothing but a set containing no elements, or if the set which is represented 6 less than 6 or greater than 5 in the rational numbers, we can write many numbers in between them, because we don't have in natural numbers, we don't have numbers in between 5 and 6. Next one, singleton set. Here singleton set. Singleton set. Singleton set means a set containing only single element. Only one element is called as singleton set. If for example it is called as singleton set, and if I represent is this a singleton set? No, because we have two elements inside the set. Here this cannot be written as singleton set. Next we can write many examples. Next one, finite set. Finite set is nothing but a set which can be said to be finite, means the elements inside the set can be able to count. If we say that here we can count the elements inside the set. How many are there? 1, 2, 3. We can write 3. There are 3 elements in the set. If I ask you to write set of natural numbers, if I ask how many natural numbers are there, can you write? No, because we cannot say how many numbers are there, how many elements are there in the set of natural numbers, because they are infinite. And the definition we can use is the set which is finite is called finite set. And next, infinite set. Infinite set means which is not finite. Finite means infinite means which is not countable, not able to countable, and like this is called as infinite. These are finite. And like this. Next one, see here, what is next one? Universal set. Universal set is we have two sets here. Two sets means 1, 2, 3, 4, and this have only 2 and 3. and this is called as universal of this, because this element is containing this. And I will say you one example in suppose real numbers, and see this chart please. Real numbers, this is the universal set. Here we can see this is real numbers, this is natural numbers, whole numbers, integer. Here we cannot find any common element in this. These are called as disjoint sets. And also the intersection, the important one is A intersection B is equal to 5, and because we do not find any common element in this, and these are called as disjoint set. The sets which are not joint, it means there is no common element or they won't be intersect, they won't be joint. These types of sets are called